In our last video, we were introduced to this concept of differentiation. And we alluded to the fact that differentiation tells us a little bit about gradients and slopes. And then we learned how to differentiate using this thing called first principles. And this is a formula that you get on your formula sheet. This is the notation here for derivative, f prime x. And we work that out by saying let the limit of h tend towards 0, and then here was the formula. And so we tried a couple of those examples, and you will be given questions in every test and exam that will ask you to differentiate by first principles. And then you don't have a choice. This is the formula you need to use, so you'll go to the formula sheet and write it down and then go from there. But if they don't specify that we need to use first principles, then we can just go with the general rules of differentiation. Okay, and we're going to sum them up in just two concepts here. So the derivative of a constant. So in other words, if f of x is equal to any constant, okay, that means something that doesn't have any variables, no letters, okay, then that derivative is equal to 0. Okay, so here's a plain and simple straightforward example. If f of x is equal to 6 and they ask me to differentiate that, then I'll say, okay, well, the derivative f prime x, this is a constant. In other words, I need to differentiate with respect to x, but there aren't any x's. And so that derivative is just 0. So that's the first thing we need to know. And then let's look at what I've called here the power rule. So if f of x is equal to something, any number, constant, times by x to the n, then the derivative works like this. You take that nth power and you bring it down to in front. Okay, so it will multiply by whatever the constant is, and then you subtract 1 from the exponent. So let's have a look at this example. F of x is equal to 8x to the 9. So this is what the rule says. We need to differentiate this. We're going to say f prime x is equal to, all right, 8 is there. Now we want to bring this power down. So we're going to multiply by 9. And most people don't show all these steps. So 8 times 9, x to the power. And then we're going to say 9 minus 1 here. So this whole step can actually be done in your head. So then we just say, what is 8 times 9? It's 72. And 9 minus 1 there is 8. So the derivative there is 72x to the power of 8. Okay, and if you can remember these two things, then you can pretty much differentiate anything that's going to come your way. It is worth noting that there are so many different ways that they can ask this. So this is just a quick review of notation. Okay, so f of x, that's our function, or y, okay, then the derivative can be written as f prime x, that's the one we know, we saw it with first principles, dy dx. So in other words, differentiating the y value with respect to x, okay, d and then subscript x of f of x, so that f of x is in brackets there, y prime, or d dx of f of x, which actually is very similar to this. It's kind of if you wrote the function as f of x instead of y, then you would use that notation. Okay, but in any of these, so they could say calculate dy dx if y is equal to something, 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 and you need to know that means derivative. And this also means derivative, and this means derivative. Okay, so very important to understand the question, because otherwise we don't know how to answer it. Okay, grade 12s, let's differentiate. Let's look at some examples of typical exam questions and how to tackle them. So determine f prime x, the derivative in other words, if f of x is equal to x squared minus 3 plus 9x over 2. Okay, so generally what I want to do is bring that down and then subtract 1. Another thing I notice here is that I've got a constant term there. Okay, the derivative of a constant is 0. And then here at the end, this one's going to be a bit tricky to differentiate in this current form. So you can expect to come across things like this. So we're not ready for this step yet. Okay, we want to find the derivative, but actually what we need to do is we need to get f of x in a form that we can differentiate. Okay, there are all sorts of other rules that you can learn if you go on to do maths in university, how to deal with this. But for now, we are going to just adapt, and we're going to say x squared I know how to differentiate, minus 3 I know how to differentiate, plus, and now we're going to use our knowledge of exponents. This would have been x to the minus 2, or could have been, and then they would have moved it to the bottom of the fraction to make that exponent positive. So instead of having 9 over x squared, we're actually going to say 9 multiplied by x to the minus 2. Okay, we can't leave our final answer with a negative exponent, but that doesn't mean that we can't use them to our advantage while we calculate. Let's differentiate. So now we're going to say, okay, f prime x, because that's what they've asked for. Okay, we're going to start by bringing the 2 down. The coefficient here currently is 1. So it's going to be 2 times 1, which is 2, x to the power of, and then 2 minus 1, which is just 1. Okay, we don't really write x to the power of 1, but I'll pop it in there for now. Okay, minus 3, the derivative there is just 0. Remember, we are differentiating with respect to x, and if there aren't any x's, then that's just 0. And then here, we're going to do the same thing. So minus 2 times positive 9, that's going to give us minus 18. X to the power of, and then be careful here, it's minus 2 minus another 1. So that's going to be minus 3. Okay, so that's differentiated, but we should be seeing a warning sign here. I can't say this is my final answer because I've got a negative exponent there. So I need to go back and just finish up. F prime x is equal to 2x, that's good, minus 0, there's no point in writing that, minus 18 is fine, that's got a positive exponent, positive 1, but x to the 3 is going to have to move under the line so that it becomes a positive exponent. So there we have the derivative of f of x. Okay, determine d dx of this thing here, the fifth root of x squared plus x cubed. Okay, so again, we want to bring the power down, we want to multiply by something, and minus 1. Okay, but in this instance, the power is a little bit complex, so we're not ready to differentiate yet. So we're going to keep writing the question. They've asked for d dx, okay, of, and now, can you remember back to grade 11, we had a rule that said if I have an exponent, so x to the power of 7, let's say, in a cube root, we can then rewrite that as x to the power, and then you take the inside number over the outside root. Outside. So in this case, inside we've got a 2, and outside we've got a 5. So I can rewrite this as something which is differentiable as 2 over 5. Inside over outside. Okay? Plus x to the 3, that's cool. I can differentiate that. Okay, and now in my next step, I'm going to differentiate that. So basically, I'm going to answer this question. So I don't need to write d dx anymore. I needed to keep writing it for as long as I was dealing with f of x here. But now if I say equals, I'm telling my marker that I am, or I have differentiated. Okay, so we want to bring this 2 over 5 down. So it's going to be 2 over 5 there. X to the power of, and now if you're nervous, you can just quickly on your calculator even say 2 over 5 minus 1, and what you should end up with is minus 3/5 there. Okay, plus, let's differentiate this one, bring that 3 down, that's going to be 3x, and then the power is now 3 minus 1, which is 2. Okay, we can't stop there. We've got a negative exponent. So let's quickly figure out how we will deal with that. Remember, the coefficient here is already a fraction. So I can simply write that. This is technically x over 1, but I can write it now as part of the denominator, and that'll solve the negative exponent. So 2 over 5x to the 3 over 5 plus 3x squared. And most markers will be happy to accept your work up until that point. But I always think it's good practice to then say, okay, well, I understand that if my exponent is a fraction, it means it came from a root. This is the inside power, this is the outside root. So I like to do one more step and say this is 2 over 5, And then there's a fifth root here of x cubed plus 3x squared. Okay, nice example there. So roots can be written as fraction exponents, and then you differentiate, and then remember positive exponents for your final answer. Okay, determine dx, d subscript x, okay, of this function here. All right, currently, I might be tempted to say, okay, let's make this x to the half, and then go for it. But actually, there's an operation here that needs to be done. So let's first do some work on that, and then we'll come to this dx part. Okay, so we're going to FOIL here. First, okay, a root of x times a root of x is just x. Then outer, root of x times minus 1 is minus 1 root x. Then inner, that's going to give us plus 3 root x. And then last, that's going to give us minus 3. Okay, there's some like terms here, these middle two. So that is going to be x plus 2 root x minus 3. Okay, and I'm tempted to start differentiating, but again, the fact that I'm sitting with this root means I don't have the exponent that I need to work with. So let's write that dx. You see, the whole time I haven't started differentiating yet. I keep writing the dx there. Okay, x plus 2x to the power of, inside power is 1, outside root is 2. So 2x to the half minus 3. And now I'm ready to differentiate. Okay, this one currently has a power of 1. So we're going to bring that down, and it's going to become 1 times x to the power of 0, which is just 1. Okay, plus this is going to be a half multiplied by 2. So that's going to end up being 1. X to the power, a half minus 1 is minus a half. And then here, the derivative of minus 3 is just 0. So we don't need to write that. Okay, 1 plus, I'm jumping the gun here. This next part here, because of the negative exponent, we want to write as a fraction. So that's 1 over x to the power of a half, or the square root of x. Okay, and like I said, most teachers probably would give you the mark if you left it at that point, but I like to give my final answer in root form. Let's have a look at one last example here. Determine f prime x if f of x is equal to this fraction here. Okay, so we need x's with exponents that we can deal with, but this one here has the fraction. Okay, and so if we wanted to go into doing that, what we're not allowed to do, let me actually say this is not okay to say, well, let me differentiate the top, so 2 times 4 is 8x, over, let me differentiate the bottom, and that's just going to be 4. Okay, let's keep that in the back of our minds, but we're not allowed to do that. Okay, the other thing that we're not allowed to do is to start cancelling. So be like 4x and then cancel the 4 and one of the x's. Okay, we can't do that because we are sitting with this minus and this plus. So we're sitting with more than one term in the numerator, more than one term in the denominator. Okay, so when all else fails us, we need to be familiar with the fact that we can factorize. So we don't know what to do, that's what you need to do. Okay, at the top here, I can't find a common factor, but I can see difference of 2 squares there. Okay, so 2 times 2 is 4, x times x is x squared, 3 times 3 is 9, and 1 gets a plus and 1 gets a minus. All right, in the denominator, 4x plus 6, we can take out a common 2 from both of those terms, and we're left with a 2x plus 3. Now, the rule of fractions, if you remember back to grade 9 and 10, is once you have factorized, you may cancel entire brackets. Okay, so now we are sitting with something that's starting to look a little bit more factorizable, differentiable. So f of x is equal to 2x minus 3 over 2. Okay, that's still not quite in a form that I would like to work with. So let's divide or distribute, is probably the better maths word. Let's give each of these terms a denominator. So we can say 2x over 2 minus 3 over 2. There we go. That is now something that I'm going to be able to differentiate. Okay, now because there's only one term here, I'm allowed to cancel those 2's. So that becomes x minus 3 over 2. And now let's differentiate. So f prime x is equal to, this is currently x to the power of 1. So let's bring that down. 1, and then that's multiplied by x to the power of 1 minus 1, so x to the 0, which is nothing. And then this is a constant. There aren't any x's here, so plus 0. So this whole complicated question ends up differentiating to something quite neat, just an answer of 1. Okay, and you'll see it doesn't equal to that. So be very careful when it comes to differentiation. The rule only applies if you've got terms that are not in fraction form. So get them all into one straight line and then differentiate. Otherwise, you're going to lose all of your marks.